All right, guys, so today we're going to be talking about exponential functions. So this is the beginning of a brand new unit that's going to be all about exponential functions. So the learning target for this week and specifically today is that you should be able to use exponential functions to model growth and decay. Okay, so make sure that by the end of this video, if you don't understand how to do that, that you make sure that you come talk to me and I can explain things further to you. Okay, as always, there is an assignment attached to this. You can view it on the classroom and then just do it on a separate sheet of paper. All right, let's get started. So these exponential functions, they're going to be in the form a times b to the x. Okay, all the time, no matter what, a times b to the x. And so what we're going to do is we're going to be talking about, again, that a is going to be our starting value. Okay, just like in sequences, when we used to have like an a sub 0 there, okay, exponential functions and geometric sequences go hand in hand. Okay, so they are very close to the same thing. My pen is not writing right now. Okay, but geometric sequences. All right, so a is going to be our starting value. B is going to be our multiplier. So that's going to be how things are growing. Multiplier. Okay, so make sure that you write those down. Okay, the other things that you need to know is, so our x value goes here. This is usually, when we're talking about exponential functions, this is usually time. Okay, so it's usually time. And my pen is not marking right now, but it's time. Okay, and then this would be the output or whatever we're trying to measure. So usually a lot of the times we do bacteria or stuff like that. All right, so here we have two different types of exponential functions. We have exponential growth and we have exponential decay. Okay, so what's the difference? Well, if you notice, okay, as we increase on exponential growth, okay, so that's over here, okay, the y values go up. Okay, so that means like over time, things are really growing. So this would be a growth model. Okay, and then this one, as time goes this way, our values go down. So this would be a decay model. Okay, so decay is when things are going down, and growth is when things are going up. Now, what you need to know is that so if you look at my two functions here, okay, I have them here. So this is f of x equals 2 to the x, and g of x equals 0.5. I'm going to write it as 1/2 to the x. Okay, when your multiplier, okay, which is b, is greater than 1, that means you're going to have growth. Okay, when your b value is less than 1, you're going to have decay. Okay, so you can imagine like 2 to the x means that you continually multiply by 2. Okay, so you multiply by 2, multiply by 2. Things are going to get really, really big, really, really fast. Whereas decay, if I keep taking half of something, so for example, if you have 100 of something and you keep halving it, so like you have 100 and then after a certain amount of time you have 50 and then you have 25 and then you have 12.5, okay, the values are going to continue to go down, and so that's how we get decay. Okay, so let's look at how we are going to set up these exponential functions using information given to us. So as you can see from the table, the population of these Iberian lynx are going down. Okay, so it went from 150 in 2003 to 120 in 2004. And according to the problem, their population is decreasing exponentially. So that's how we know to use an exponential equation. So that's again a times b to the x. Okay, so a is usually pretty easy to figure out. It's going to be your first value. So in our case, that's 150. B is a little bit more difficult. So if you imagine b is the multiplier, okay, so what I need to know is 150, and multiplier meaning I need to multiply, 150 times what is going to give me 120? That's a 0. Okay, and so in order to solve for that, if you imagine if I'm multiplying, to solve, all I do is divide by 150 on both sides. And so those cancel, and I get that the question mark equals 0.8. Okay, so this is going to go in to my multiplier. Okay, so I can write my equation. F of x equals 150 times 0.8 to the x. Okay, so then to answer the question, how many are left in the world today? Well, we just need to sub in an x value. So for example, f of x equals 150 times 0.8. Now we have to think, we're going to sub in years since 2003. Okay, so it's 2017 right now, minus 2003. Let's see, it has been 14 years. So this is going to go in for x. Okay, so then we got to grab our calculators and do 150 times 0.8 to the 14th power. Okay, and I get right around 6.7. So, and typically what we do with, if you imagine there's not 0.7 of an Iberian lynx out in the world, so we usually round it to the nearest whole number. So we're going to say that there are 7 Iberian lynx, L-Y-N-X, left in the world. Okay, so that would be our answer. Okay, again, if you're struggling on figuring out what A is or what B is on any of the problems or how I got them in this video, make sure that you ask. Okay, I'm not here just to sit around and do nothing, so make sure that you come ask me. All right, so let's look at a different situation. Let's look at what if they tell us in the context of a problem our numbers. So for example, the last one I had a table, so I had to figure out B and all that stuff. So let's suppose now that a population of 120,000 grows 1.2% every year. Okay, so if we're going to make our equation, f of x equals a times b to the x. Again, a is going to be what I start with. That's 120,000. Okay, 120,000 people is what I start with. Now, to figure out b, it's kind of like if you think back to geometric sequences. Okay, 1.2%, well, in order to grow by 100 or 1.2%, I take 100% plus 1.2%. And what do I get? I get 101.2%. Okay, and so in order to get B, all I need to do is convert this to a decimal by moving the decimal place 2 times. So 1.012 becomes my B value. Okay, so if I rewrite my function now that I have it, I get 120,000 times 1.012 to the x. Okay, well now, how big is the population after 15 years? Well, that 15 is just going to go straight in for x, and I'm going to type it into my calculator. So, give me a second. I do 120,000 times 1.012 to the 15th power, and I get 143,512, and technically I get 0.2, but again, like I said in the last problem, we usually round it to the nearest person or nearest whatever we're talking about. Okay, so there's about 143,512 people after this population grows for 15 years. Okay, as always, if getting B doesn't make sense or getting A doesn't make sense, make sure that you call me over so that I can explain it. All right, and lastly, what we have to do is we have to be able to look at a graph and be able to figure out what the exponential equation is that we're looking at. So again, I got to think about f of x equals a times b to the x. Now A, remember, is our start. So that's our y-intercept on our graph. So if you imagine, that's right here. Okay, and so what is that value? That value is 2. So A has to be equal to 2. Now, how we're going to do this is very similar to how we did it with a table 2 problems ago. So if you imagine, one of my points is, so if this is x and y, 0, 2, which is the point I already have. But if you look at the next point, 1, 4. Okay, so all I need to figure out is what am I multiplying by, okay, because b, again, is the multiplier. Ran out of room. But I just need to know what am I multiplying by to get to 4. So in this case, 2 times what is 4? Well, 2 times what equals 4. And of course, you know that 2 times 2 is 4. Okay, so I know now that b is 2. So to write my equation, I'm going to go f of x equals 2 times 2 to the x. Okay, again, just like all the other times, if it doesn't make sense how I got A or how I got B, just ask and I can explain it in a different way. Okay, so remember that the learning target is that you should be able to use exponential functions, okay, to model situations. Okay, if you cannot do that or you do not feel comfortable doing that, make sure that you ask. Okay, if you do feel comfortable, move right on into the exponential functions practice. Now, if there's certain ones that you don't know how to solve, definitely call me over. There's a few that all I want you to do is set up. So for example, I just want you to find this equation for each one to begin with. So if you go through, make sure that you can get f of x equals a times b to the x. And then if you feel like you're comfortable enough solving them, go for it. Okay? As always, ask questions if you don't understand. Thanks for listening.